Actions of Onagawa Nuclear Power Station to enhance safety. On March 11th in 2011, the Great East Japan earthquake occurred. Onagawa Nuclear Power Station was the power station closest to the seismic center, distance of about 130 kilometers. This earthquake recorded a magnitude of 9.0, which was the strongest ever recorded in Japan, an intensity of 6 lower at Onagawa Nuclear Power Station, and an earthquake acceleration of 567.5 gal. Gal is a unit to express the instantaneous force applied to people and buildings. In other words, the intensity of the shock of an earthquake. The influence of the earthquake resulted in ground subsidence of the entire Oshika Peninsula by about 1 meter, and a gigantic tsunami of at most 30 meters high surged into the power station. Talking about the status of the power station before the earthquake, reactors number 1 and 3 were in normal operation. Reactor number 2 had just started up at 2 p.m. immediately before the earthquake for trial operation toward the final stages of periodic inspections. In such an emergency, securing safety is most important. Onagawa Nuclear Power Station promptly took the following actions. Number 1. Shutdown of the reactors. When the reactors detected severe shaking due to the earthquake, the control rods were inserted immediately as designed, and all of reactor number 1s to 3 stopped automatically. Number 2. Cooling of the reactors. In the case of nuclear power generation, the fuel keeps generating heat even after the operation is stopped. Therefore, the fuel in the reactors must be cooled continuously. Electric pumps are used to cool the reactors by circulating a huge volume of fresh water and seawater. Thus, to ensure the safety of a nuclear power station, electricity and water are crucial. In Onagawa Nuclear Power Station, where electricity and water were readily available, the cool-down operation started immediately. Consequently, reactors number 1 to 3 reached a stable state of a cold shutdown by around 10 hours after the earthquake. Number 3. Containment of radioactive materials. In such an emergency, containment is important to prevent radioactive materials from being released outside the power station. After the earthquake, the radiation monitors placed within the power station site did not show abnormal values. Onagawa Nuclear Power Station assumed earthquake and tsunami damage from the design stage and continuously reflected the latest knowledge in safety measures at different times. Thanks to the preparations, the operation to ensure safety, which was the shutdown and cooling of the nuclear reactors and the containment of radioactive materials, functioned normally even when the Great East Japan earthquake occurred. Onagawa Nuclear Power PR Center is located on high land, and on the day of the disaster, local residents came for help. The tsunami swept away their houses and caused supply shortages. It was a serious situation. They moved to the gymnasium in the land of this power station, and 364 people at the most took shelter for about 3 months with the employees of this power station. Onagawa Nuclear Power Station overcame the disaster by preparing for 3 eventualities. The first one is preparation for tsunamis. Since planning of reactor number 1, tsunami have been taken into account, and the height of the power station site was set to as high as 14.8 meters. Therefore, the tsunami did not exceed the site height. When the height of the site was determined, the height of a tsunami was originally assumed at about 3 meters, based on surveys and records of previous tsunamis. However, the Sangiku coast suffered huge tsunamis since early times. In light of that fact, an internal committee that included academic experts further held series of discussions and the site height was determined to 14.8 meters. When reactor number 2 was planned, the simulation technology for tsunami height had been advanced. That led to re-estimation of the assumed tsunami height to 9.1 meters, and protective concrete structures were installed up to the height of 9.7 meters in order to reinforce the slopes at the site. Moreover, in 2002, it was confirmed that the assumed tsunami height of 13.6 meters, which was estimated by the evaluation method of the Japan Society of Civil Engineers, incorporating the most recent findings at that time, did not exceed the site height. Although the influence of Great East Japan earthquake caused ground subsidence of the entire Oshika Peninsula by about 1 meter, and the height of the site decreased from 14.8 meters to 13.8 meters, the surging tsunami of 13 meters in height never went beyond the height of the site thanks to this preparation for tsunamis. The second one is the preparation for earthquakes. Handrails were installed in the central control room where operators control the power station, as well as the amendments to the Japanese regulatory guide for reviewing seismic design and the knowledge on earthquakes experienced previously were referred to. In total, 6,600 seismic projects, including piping inside the buildings, had been conducted by 2010, which was before the earthquake. While the office building was used for desk work at the time of the earthquake, the seismic work on the buildings such as bracing had also been completed. In this way, we also prepared for earthquakes, the same as the preparation for tsunamis. The latest knowledge at different times was collected as needed, and the preparation had been enhanced continuously. Thus, the safety of the power station was secured. The third one is preparation to ensure electricity and water. To guarantee electricity and water required for the safe shutdown and cooling of reactors is so important as to say that it is a lifeline of nuclear power stations. Let's start with electricity. To shut down reactors safely and to make seawater pumps work for cooling the reactors, even after the shutdown, electricity is essential. Onagawa Nuclear Power Station has 5 external power lines. One of them was undamaged after the earthquake. On the next day, which was March the 12th, the situation improved and 3 lines were available. Nuclear power stations have more than 1 emergency diesel generator, providing advance to secure electricity used in power station even in the case of no electricity transmitted through power lines. The emergency diesel generators can realize steady state if each reactor building maintains 1 unit. Onagawa Nuclear Power Station was provided with 8 diesel generators in total to prepare for emergencies. Though 2 units failed because of the inflow of the seawater, the remaining 6 units were secure and ready for power generation. In addition, electricity could be flexibly shared among reactor buildings. Thus, the preparation to ensure electricity was implemented. The next topic is preparation to ensure water to cool reactors. In Onagawa Nuclear Power Station, important facilities were not located in the harbour section that would easily be affected by tsunamis. For example, seawater pumps essential for cooling the reactors with water after the shutdown were installed in pits of bedrock, which were dug into the ground from the site height of 14.8 meters and separated per pump by walls. What's more, the measures for undertow conditions were implemented. The path from the intake to the seawater pumps were designed to be ramped so that the emergency seawater pumps could continue operation with reserved seawater in the intake channels. Although the nuclear power station was the closest to the seismic center, the operation to ensure its safety functioned normally thanks to the daily training and preparations before the earthquake. Onagawa Nuclear Power Station went through the investigations by the International Atomic Energy Agency, IAEA, in the next year of the earthquake and was evaluated as remarkably undamaged. In addition, in 2013, the World Association of Nuclear Operators, WANO, appreciated the preparations for safety and the actions for local residents and presented the Nuclear Excellence Award. Onagawa Nuclear Power Station safely shut down the reactors during the Great East Japan earthquake. After the experience of the earthquake, we learned lessons from the accident at the Tokyo Electric Power Company, TEPCO, Fukushima Daiichi Nuclear Power Station, and now take new action to further enhance safety measures. Let's take a look at the new safety measures of preparations for 5 eventualities. To safely shut down the reactors, the preparation for tsunamis and earthquakes is important. Number 1. Preparation for tsunamis. As the preparation for tsunamis, the assumed height of tsunamis at the power station has been re-estimated to 23.1 meters and the seawall at a height of 29 meters above sea level, which is high enough to avoid tsunami damage, has been constructed. The new seawall consists of approximately 680 meters long steel pipe piles, a vertical wall, and approximately 120 meter long embankment of cement-improved soil, all of which are 800 meters long in overall length and positioned to protect Onagawa Nuclear Power Station from large tsunamis. Number 2. Preparation for earthquakes. For preparations for earthquakes, the reference ground motion, which represents the intensity of the shock of an earthquake assumed in the vicinity of the power station site, was set to 1000 gal and further seismic work is being carried out. Number 3. Preparation to ensure electricity and water. Preparation to ensure electricity and water is necessary to cool the reactors. To ensure the stable supply of electricity, a gas turbine power generating facility is provided on high land. The tank for diesel fuel was placed underground in order to avoid the impact from large earthquakes and tornadoes as much as possible. For securing water, a freshwater storage tank with a capacity of 10,000 cubic meters was installed on high land. And a high-capacity water pumper truck capable of pouring water directly onto the reactors has been deployed. For serious accidents, this high-capacity water pumper truck is used to directly or indirectly supply water from the freshwater storage tank onto the reactors and the spent fuel pool. Moreover, the heat exchanger unit has been provided to remove heat from the reactors. Number 4. Preparation for containment of radioactive materials. In an emergency, safe containment of radioactive materials is especially important. With respect to the accident at the TEPCO Fukushima Daiichi Nuclear Power Station, the reactor containment vessel, which functions to contain radioactive materials, and the pressure vessel were damaged, resulting in hydrogen explosion. We implemented precautions to prevent such cases. For example, the placement of hydrogen recombiner that controls the accumulation of hydrogen generated from the damage of the nuclear fuel is currently in progress. In addition to the installation of a containment vessel venting device equipped with a filter that reduces the volume of radioactive materials emitted to 1,000th or less in the event of an accident. Number 5. Preparation for various disasters and risks. The preparation for disasters and risks other than tsunamis and earthquakes are also made. For example, a fire line is provided around the sites of the power station in order to prevent forest fires from spreading to the power station. Regarding the preparations for a large-scale nuclear disaster, establishment of the Emergency Response Center in a seismic structure will be constructed. The center has the command office function as a local countermeasure headquarters on high land. Moreover, the facilities to secure the safety of the nuclear power station in case of a terrorist attack will be installed. Humans actually run these facilities to increase safety, to maintain and improve the capability of the power station staff to respond in an emergency. They are trained continuously under the assumption of various situations. The training in collaboration with related organizations, such as local governments, are also conducted. For reactor number 2 of Onagawa Nuclear Power Station, the assessment of conformance to the new regulatory standards pursuing world's highest level of safety is currently conducted by the Nuclear Regulation Authority. We make efforts not only to pass the new regulatory standards, but also to enhance safety. In parallel, in order to reassure local residents, we will continue to take firm action for both precautions with regards to the facilities and preparations that include education and training, and intend to be active in disclosing information.